Anytime there's a new design procedure, it's always good to get acquainted for the design procedure and a feeling for how sensitive it is to the different inputs and also the types of designs that it produces. And this presentation is going to go through the BCOA-ME design procedure and give you an idea of the sensitivity there is within the procedure of each of the inputs to the design thickness, and then go through some design examples or case studies. And we're going to establish a base design, and then we'll vary these inputs from these base values. So we're assuming that this overlay is constructed in Minneapolis, Minnesota. The asphalt thickness after milling, just prior to the placement of the overlay, will be 6 inches. The HMA condition is adequate, so you have about 0 to 10% fatigue cracking. The composite K value of all the layers below the asphalt then will be 250 psi per inch, so pretty standard values. The concrete strength will be a typical paving mix with about a 650 psi fluxual strength correlating to around a 4 million psi elastic modulus, and a typical thermal coefficient of expansion of 5.5 times 10 to the negative 6 microstrain per degrees Fahrenheit. The joint design that we'll look at will be 3, 4x4, 6x6, and 12x12 panel sizes. So the first thing we're going to look at is the sensitivity of the overlay thickness to panel size. So here we have overlay thickness on your y-axis and design easels on your x-axis. And with all these graphs, you'll see that the BCOA-ME overlay thickness predicted will be in black, and then the Colorado procedure will be in red, and the ACPA procedure in blue. Now, the AC procedure was the original procedure used for predicting the thickness of ultra-thin overlays, and the Colorado procedure was the traditional procedure used for predicting the thickness of thin overlays prior to the BCOA-ME. And so this is why we're making comparisons. The 4x4 would be compared to the ACPA procedure, where the 6x6, the Colorado, and also the Colorado for the 12x12, because this is what was available prior to the BCOA-ME. Okay, so the first thing that you'll notice is that traditionally we assume the smaller the slab size, then the smaller the stresses and the thinner the overlay can be. And that's why you see the ACPA for the 4x4 predicted thinner overlay thicknesses than the Colorado procedure for the 6x6 and the 12x12. But what we have found is that when you have the smaller panel sizes, then the longitudinal crack tends to ride right in the wheel path, and you get a more rapid rate of deterioration. And so in reality what happens is these smaller panel sizes where you have the wheel path riding right along that longitudinal joint, you tend to have to need a thicker pavement to get the same performance as a 6x6 where you're outside, the wheel path is outside of that longitudinal joint. And this is reflected in the BCOA design procedure. So the 6x6, you'll see the thickness here, and then the 4x4 thickness would be up here for the BCOA-ME, and again that reflects the load being applied directly on the longitudinal joint. And also when you increase the slab size from 6x6 to 12x12, of course you're going to need to increase the overlay thickness as well, because then with that much of a significant increase in joint spacing, your curling stresses become more dominating. Alright, so modulus of rupture for the 4x4. So here we're just comparing to the ACPA, which was typically used for the ultra-thin white topping. And we're going to look at two different strengths, 750 and 550, which one would be pretty high and the other would be on the lower end. And so you'll see that we have thickness versus traffic, and again this is a 6-inch asphalt layer that we're placing the overlay on top of, and here we have for let's say 1 million easels, we need about a 2-inch overlay with the old procedure, and with this procedure with the 750 psi we need 4 inches. And then this just increases by 1 inch for the BCOA procedure when you're decreasing your strength to 550, and by a couple of inches for the ACPA procedure. If you're looking at the 12x12, you'll find that for the BCOA-ME, your overlay thicknesses are more stable when you get to really thin asphalt layers and really thick asphalt layers. So for this, we're looking at the thickness with respect to the thickness of the asphalt, assuming we have 1 million easels. And they tend to predict similar thicknesses when you're comparing the Colorado, the older procedure, with the BCOA-ME for the higher strength. For the lower strength, you see that it's a lot more sensitive with changes in asphalt for the original procedure, the Colorado procedure, and a little bit more stable for the BCOA-ME procedure. And the stability you see in the BCOA-ME procedure at this end compared to the Colorado procedure as well. It's not very sensitive to the K value, so here we're looking at 6x6 panels, and so you don't see a significant difference. Again, the concrete pavement, the overlay, and the asphalt are carrying the majority of the load, so it's not very sensitive to the supporting layers underneath. With most concrete pavements, again, it's uniform support in those lower layers. Whether it's weaker support or stronger support, as long as it's uniform, you're going to be okay. And again, it shows the instability when you get to the lower thicknesses for the older procedures, and it's more stable for the BCOA-ME. Next, we're going to look at the sensitivity to climate, and you'll notice that we don't have the older procedures on here, the ACPA or the Colorado DOT procedure, because they didn't consider climate within those procedures. So for the 4x4, it's not really sensitive to climate. Again, you have very small slab sizes, and so it's not as sensitive to the curling and the warping because the slab sizes are so small. When you start to get to the 6x6, you see a little bit of an increase in the sensitivity with respect to climate. And then with the 12x12, your panels are much longer. It becomes substantially more sensitive, as you would think. Again, this was not compared to the ACPA or the Colorado DOT procedure because those weren't directly incorporated into those design procedures. So now that we've seen a little bit on how sensitive the design thickness is to these various inputs, we're going to go to the next step and look at different case studies. So we're going to say for these pavements that have been constructed, and most of them were designed and constructed at a time when we didn't really have a procedure available, so it was just a best guess, if you will. So we'll compare these procedures with their performance and the predicted overlay thickness that would have been provided by the BCOA, as well as with the older ACPA and Colorado DOT procedures. I should mention here too that the BCOA app put out by ACPA is quite similar to the ACPA procedure. It was just the ACPA procedure incorporated into that app. Okay, so going back to our design examples, this project was constructed in Rochester, New York. 4x4 foot panel spacings were used. We had a design traffic of about 0.8 million. The asphalt thickness after milling was 9.5 inches, so quite thick. And again, this is in the extremities where we see a substantial difference between the old procedures and the BCOA-ME. The asphalt condition was marginal, so about 10 to 20% fatigue cracking, a composite K value of 250 psi per inch, compressive strength around 5,000, the CTE, the coefficient of thermal expansion was 6 times 10 to the negative 6 microstrain per degrees Fahrenheit. Now, with each of these examples, I'll give the actual project definition. Above the line and below the line, we'll have the design comparisons. And here we'll have the BCOA-ME and the traditional or the older design procedure used prior to the BCOA-ME, and then how the pavement actually performed and what was actually constructed. So the BCOA predicted that you needed a thickness of about 4 inches, the ACPA at 2.5. Again, that's because when this gets high, this gets extremely sensitive, and so it drives that thickness down. So for almost 1 million easels, it's saying you only need about 2.5 inches of concrete. Okay, what was actually constructed was 4 inches, and here we're about halfway through, a little bit more than halfway through the design life. We have a few corner cracks, so it seems that the BCOA probably did or would predict a reasonable design for this project. Now we're going across to Illinois, and we have lower traffic here with 0.14 million easels. Again, an asphalt thickness of 4 inches, and here we have a modulus rupture of 600. So what was built was 5 inches. It at 0.04, so about a third of the way through. We don't really have much cracking at 0.2% crack, so very little. What the BCOA-ME predicted was 4.42, or what we would probably design would be 4.5, and then the Colorado procedure was 6.5, so it's substantially thicker for the older procedure. So again, it seems like we have some reasonable predictions in our design here. Another project in Illinois where we have 6 foot by 6 foot joint spacing, and here we're at 0.3 million easels and 3.5 inches of asphalt. Again, that really influences the old designs. Here we have about 4.5 on top of that. Just under 6 inches was constructed, and we're, let's say, about a third to a fourth of the way through the life and still not really exhibiting much cracking at this point. So the last design example I'm going to show you will be up at the Minroad site test section. Well, it was a section overlay placed on I-94 outside of Minneapolis, Minnesota, and this was on a relatively thick asphalt layer, 10 inches. The traffic that it saw through the design traffic was 4.8, and this did actually see 4.8 million easels, so we'll have an end-of-life example here. And this example was brought in because the structural fiber was used, 25 pounds per cubic yard. So when the design procedure considered a structural fiber, the BCOA-ME then predicted a 3-inch overlay thickness. The Colorado was predicting 4, and then the as-built was 3. So we had 20% cracking, pretty much failure at 4.8 million easels, and so we had a pretty good prediction here. Just to give you an example of how the fiber does influence the thickness, if we did not consider fiber for this exact same design, then we would have predicted a necessary thickness of 4 inches. And we don't know how it would have actually performed without the fiber, but you do see that in this scenario we needed another inch without the structural fiber. And it is more influential with these lower, the thinner overlays that we're looking at, 3 inches and less. So these are the design examples and the sensitivity analysis that we performed, and hopefully it gave you a better feeling for the predictions of the BCOA-ME and what parameters it's sensitive, and gives you a better feeling when you go out to use it.